Hey, this is part 3 of verifying trig identities. Again, we're using this book by Glencoe, it's just pre-calc. We're on page, what is it? Nope, not that one. Yeah, this is all going to be in the video. I'm not redoing this. We're on page 324 still, if you want to get this book. We've done, I think we're on number 22, and we'll finish that up today. 22 through 31 on page 324. Let's go. All right, so like I've been saying, where's that other board? The one that has all the stuff you need. Oh, it all got messed up. Well, look at the other videos. We got kind of erased, but that's what we're using, the Pythagorean identities and the reciprocals for the most part. And I tell my students, if we have like cosine over here, that means this stuff needs to get changed into sine and cosine, and that's where we are going to start. And we're going to find common denominators. So many of these problems are the same. So on the top, cosine minus sine, all over cosine. And the bottom, sine minus cosine, all over sine. So we have we have three fractions. We have a fraction on top, then we have our actual whole fraction, and then we have our fraction on the bottom. We are dividing by a fraction, which means I'm going to multiply by the reciprocal of that fraction. Let's continue over here. That is going to be sine squared, and I forgot my theta. Sine squared theta. So that one goes on top here, times cosine theta minus sine theta. All over. Cosine stays in the bottom. Cosine theta. And that's going to be sine squared theta minus cosine squared theta. There you go. Looking at my answer here. So we're going to have, I need to get only sines here, or only cosines, sorry, my sines need to disappear. These are almost the same. Very close. I'm going to do that thing I did a few problems ago where I take a negative out. So I factor a negative out, and it doesn't matter if it's top or bottom. And I'm going to get cosine squared and sine squared. And that negative allows this piece here to change to positive cosine, negative sine. Or I could have changed this one to positive sine, negative cosine, which would have matched this. It doesn't matter which one I do, as long as I can delete them. And I can. Goodbye. So negative sine squared over cosine squared. Now I would have thought the book would have said to find negative tangent squared, but they don't. They want us to find this here. So I know sine is 1 minus cosine squared. And cosine squared here. This negative, when I put it in, when I distribute it, I get positive cosine squared minus 1 over cosine squared. And that's our answer. And there you go. That was 22. 23. All right, so I see here I have one term, and I need two terms, so that's a big old fat indication that I need to split this fraction up. Oh, nope. Cosecant over over secant plus, that is 1 over sine over 1 over cosine. 1 over secant, that equals cosine. 1 over sine divided by 1 over cosine. If I'm dividing, that means I multiply by the reciprocal. So I'm going to get plus cosine over sine. And that's our answer. Cosine theta plus cotangent theta equals cosine theta plus cotangent theta. Bam. There you go. Number 23. Number 24. Now, I know my students, even at this level, some of them are going to say, oh, that's cosecant squared minus cotangent squared, because you just apply the square to both of them, right? No, got to FOIL that out. So I'm going to get cosecant squared minus 2 cosecant cotangent plus cotangent squared. And let's go ahead and change all this stuff into sine and cosine, because look, on our answer here is only cosine. So I can't have any of this nonsense in there, just sine and cosine. It's not squared, is it? Nope, it's not. This is. So let's simplify this one more step. I don't want to skip it and confuse people. I have 2 times cosine on top, and I have sine squared on the bottom. So we can actually combine this entire thing into one term. So I'm going to have cosine squared. I'm going to rearrange this a little bit. Cosine squared minus 2 cosine plus 1 all over sine squared. Now, looking ahead here, my answer still is only cosine. Oh, some of that's off frame. Sorry about that. Only cosine, and I have a sine down here, so that's not going to fly. So I need to change that. So that'll become 1 minus cosine squared. So now I have only cosines. And on top, I have cosine squared minus 2 cosine plus 1. And if I factor that, I'm going to have 1 and negative 2, negative 1, negative 1. So I'm going to have x minus 1, which is x minus 1 squared. Or is it 1, no? 1 minus 2. Oh, it doesn't matter, okay. Cosine of theta minus 1 squared. Again, I'm not going to erase this. I'm not going to refilm this. Let's keep this in this order here. 1 minus 2 cosine theta all over sine squared theta. And that's going to become 1 minus cosine of theta squared And then again, sine squared is going to be 1 minus cosine squared. Let's see if we can squeeze this in here. So I'm going to write smaller here, 1 minus cosine, and I have two of those, 1 minus cosine. Factor the bottom, this is a difference of squares. 1 minus cosine squared is the difference of squares, so that's 1 minus cosine, 1 plus cosine. And there is our answer. 1 minus cosine, 1 plus cosine. That's it. If I could bring this up just a little bit. There we go. All right, on to number 25. Plus tangent squared, 1 minus tangent squared. Have cosines over here, don't have any cosines over here yet, and only cosines over here, so these tangents need to be changed. So let's change those into sine over cosine. And like we've done 100 times, we're going to find common denominators. So we have cosine squared, this is just on the top here, plus sine squared over cosine squared. And on the bottom, cosine squared minus sine squared all over cosine squared. So when I flip all this stuff, and actually these are gone now since they are the same denominators. So let's go cosine squared plus sine squared. Cosine squared minus sine squared. And you can see on the top there, that is my Pythagorean, there we go, Pythagorean identity, which is just 1. There's our 1 right there. 1, 1, 1, 1. So we have our 1s. I need only cosines down here. I have a sine down here. I can't have that. So this is going to go all over the place, but our next step is going to go right there. So I have 1 over, that's our 1 again, cosine squared minus, and sine squared we know is 1 minus cosine squared. Pythagorean identity. So we're just about done. This negative, or this minus 1, or whatever you want to call it, gets distributed to both of these pieces. So I get positive cosine squared, so I get 1 over cosine squared plus cosine squared is 2 cosine squared, and then minus 1. That's our answer. All right, number 26. Again, excuse me, look at your answers. We only have cosines in our answers, so tangent, that's got to go, and eventually sine is going to have to go too. And if you're used to Pythagorean identities, this should be a no-brainer for you. I'm left with sine squared, and I have to make that equal to 1 minus cosine squared, and we know sine squared equals 1 minus cosine squared. So we're done. All right, 26 or 27. Dude, I'm in the middle of recording a video. Get out of here. 27, secant minus cosine. All right, let's go. This is 1 over cosine minus cosine. Common denominator, so that's going to be 1 minus cosine squared all over cosine. And check it out. Hang on a second, what is that, cosine? One minus cosine again. Gosh, we've done this so many times. Over cosine. I'm going to split that up into sine over cosine times sine. And how did I know to do that? Right here, that's our answer. So sine over cosine gives me tangent times sine. All right, number 28. Oops, that's not it. That's my first step. Sorry. I wrote this one out ahead of time, so my bad. So that needs to equal 2 secant squared minus secant to the 4th. So yeah, my left side, this is the difference of squares here. So I have 1 minus tangent squared and 1 plus tangent squared. And remember Pythagorean identities, 1 plus tangent squared gives me secant squared. And let's look at our answers. We have only secants. I don't have any tangents left in there, so that's got to change too. So tangent squared equals, and we have that in our Pythagorean identities, secant squared minus 1. One minus a negative 1 gives me 2. Hey, there's our 2 right there. 2 minus secant squared times secant squared. And you can see we're going to have our answer right now. Distribute this secant squared to both pieces in here. So I get 2 secant squared theta minus secant squared times secant squared is going to give me secant to the 4th. And that's it. Always be checking your answers. I only have secants over here, so that's why I changed this tangent squared into secant squared. So when you get stuck, look at your answer. Look where you need to go. 29. No, I'm recording a YouTube video.
Sorry.
A very important YouTube video.
Sorry.
Like it's going to be world changing.
No way.
Yeah. I'm going to get at least like 4 views on this.
Actually?
Maybe.
That's crazy.
I know. Okay, so same thing. Is this the same as number 24? Is this the exact? Did they put 2 of the same problems in? Wow, I've never seen a book do that before. This is the same as, might as well call this one 24 or 24 because it's the same thing. Seems like somebody should have caught that. Okay, that was a good one. Easy, no problem. Let's go on to number 30. Now I have kids every year that see sine plus cosine and they get so like, oh, that equals 1. That's not a Pythagorean identity. Sine squared plus cosine squared is. Sine plus cosine is nothing. So like always, we're going to go ahead and just change this tangent into sine over cosine, and we'll get going. Common denominators. I feel like we're doing the same thing every single time. All over cosine, and you can see where this is going. Dividing by this, which means I'm going to multiply by the reciprocal of this, which means it's going to be cosine x plus sine x all over cosine times this reciprocal here. So sine x, where'd that x come from? Get in there, theta, plus cosine theta. So those are gone. I'm left with 1 over cosine, which of course gives me secant. All right, and last but not least, number 31. Sorry, secant. And that equals sine plus cosine squared. Let's get going. So we're going to have 2 plus 1 over sine times 1 over cosine. All over 1 over sine times 1 over cosine. And as I'm writing this out, understand that this isn't the only way to solve these. So 1 over sine cosine. 1 over sine cosine. Let's do sine cosine top and bottom. Probably was an easier way to do that, but we're going to end up with this becomes 1 down here, so we'll have 2. Shoot, I'm going to run out of room. So I can block this off here. 2 sine cosine plus 1, and this is where we're going to have to really get creative here. And that's over 1, right? Because this right here becomes just 1. Now, how do we get from here to here? That's the tough part. We're going to go backwards on our Pythagorean identity. I know 1 also equals sine cosine, or sine squared plus cosine squared. Ooh, fit that in there. So let's rearrange this. Gosh, I'm running out of room. This is a tough one. I'm sure I'm going to get questions about this one. So if I say sine squared plus 2 sine, I'm just rearranging right now, cosine plus cosine squared, and I factor that. Let me see if I can write this out on the second whiteboard here. X squared plus 2xy plus y squared. That's actually this right here. X squared plus 2xy plus y squared. Sine squared plus 2 sine cosine plus cosine squared. So that's what we have here. And if you factor that one, you end up getting x plus y squared, which is our answer. Sine plus cosine squared. So again, that's what we got here. This one is tough. Knowing to go from this 1 to expanding it back out, which we've been doing the opposite of every single time. Knowing to multiply this, I think we could have had an easier way. I know the video is just about done, but I'm curious if I would have gone from the beginning. And you're just going to have to sit through this, or you can stop it because it's a video. If we skipped, nope, it'd still be the same thing. We'd still end up with this here, and we'd have to know to expand it out. So anywho, there you go. There's the last piece. Enjoy it. The 6 of you who watch this, please subscribe and tell your friends and leave comments about my great handwriting. Anywho, later. Take it easy.